Hey folks, welcome back to another science lesson. Today we're going to be talking about energy, our second time talking about this unit. Hey guys, if you're in my class, make sure you check out Schoology to update yourself on that energy in the news project. Make sure you pick a couple of articles, have them read, and save those links so you don't forget what you've done. All right, today we're going to compare and contrast some of the things we did yesterday as far as potential and kinetic energy. So let's go ahead and draw two big circles. One for kinetic and one for potential. So what would we do? We would put things that explain or define the terms in the circles and any related terms in the middle. Kinetic energy is energy of motion. And opposed to that, potential energy is energy of position or shape. What do I mean by that? Okay, so the position of an object is going to determine its potential energy. Objects up on a hill or on the side of a desk are going to have potential. In other words, the ability or potential to fall and get moving. Now, it's not moving yet or now, but it could. The higher up an object is, the more potential energy it gains. And what do I mean by shape? Think about a bow and arrow. A regular bow, and here's the string, has no energy, but when you pull that string back, you've changed the shape of the bow, and now you've increased the potential energy in the system. Let's think of some examples. Kinetic energy being energy in motion. Let's say a roller coaster. What about potential energy? Let's think of an object that has potential energy. Let's think of a roller coaster. Why do I say both? Same example. Why? Because a roller coaster is a good example of motion. As your roller coaster car is moving, you're gaining energy, therefore you've got kinetic energy. But as you go up to the top of the hill, your car slows down, gaining potential energy. So here's an example of something that has both kinetic and potential energy. And they're both forms of energy, of course. Now, when you combine your potential energy with your kinetic energy, you get mechanical energy. Mechanical energy is the sum of potential and kinetic energy in a system. Think of a piece of machinery. Okay, today we're going to find out about a lot of different forms of energy, so have your notes ready to go, and we're going to quickly go through all the different types of energy, starting with the most basic fundamental type, the energy that's found in matter. That's nuclear energy. The energy stored in the strong force of the nucleus. You remember a nucleus is made of positive protons, neutral neutrons. Those positive forces would want to repel, so there's a strong force keeping those positive particles close together. That's opposed to the forces that keep atoms together in a molecule, such as water. Those bonds, although strong, can be broken. Okay, a simple campfire can break apart the bonds between atoms. But to break apart an atom itself and break apart the parts of the nucleus is going to take quite a bit more energy, and you get quite a bit more energy out when that happens. There's two things that could happen. Fission, which is the splitting of an atom's nucleus, creates a big explosion. We call it a nuclear explosion. You've got a large atom here, maybe uranium or plutonium, and a neutron hitting it at enough speed can actually cause that to split. Now we've got two smaller atoms and some extra neutrons that will go ahead and hit the next. All right, when you get time, I'm going to put some videos in our class folder, and you can check out what these guys did to simulate the fission of a nuclear explosion. Fusion happens on the sun, where you have two smaller nuclei, such as hydrogen, joining together, combining a larger atom, and then creating some energy as a byproduct. So the sun is combining a lot of hydrogen atoms, millions per second, into helium, and that releases energy. Someone smart figured out that energy can be calculated as the mass times this c constant, which is the speed of light, squared. It's a huge number. So even though the mass of these atoms are small, this is such a huge value that energy can be actually measured in this process. And there it is. Thermal energy, you might call it heat. Thermal energy describes the molecular motion of something. So we've talked about this before when we talked about melting and freezing and evaporating. Really, we were talking about the speed and motion of molecules. So if something melts, the molecules speed up, move farther apart. That's what we're talking about. The energy of motion of the actual molecules. Now, since it's energy of motion, you can think of it as a form of kinetic energy. The more molecular motion, the higher the thermal energy. Or heat. And we're going to talk a little bit more later on in the unit as far as what's the difference between words like heat and temperature and thermal energy. But for now, these are common terms we all would understand. Check later the video about the expansion of liquid nitrogen. That's quite explosive. Electromagnetic energy, not to be confused with electricity or magnetism, although it's related. We're talking about a type of energy that you would probably just call light. Energy that travels through space as waves. This could include light, microwaves, X-rays, infrared, radio waves, gamma wave. You've probably heard some of these terms, commonly referred to as the electromagnetic spectrum. The only difference between light you can see and light you can't see, like an X-ray, is the wavelength, is the length of this wave, okay, which is going to affect the frequency. So things that we can see, our eyes are tuned to, would fall into this spectrum here, but the spectrum continues on in both directions and includes all these different forms of energy. There's a really good video about the electromagnetic spectrum. Make sure you check it out. Electricity. Again, this is a movement type of energy, so I could consider it a kinetic movement of, this time we're talking about electrical charges. So remember, back to your atoms, we have the neutral neutrons, the positive protons, and then the negative electrons. The electrons are on the outside of the atom, free to move around, and actually free to transfer from atom to atom. So we can have a buildup of some negative charges, or in other words, electrons, and they'll move towards a positive source. And if you have a wire in between, that motion, that movement can be measured, and it can be used to make all kinds of things happen. And that's electricity. You also see electricity in nature as far as the buildup of static charges in a cloud. So static electricity, just like when you rub your feet on a carpet and touch a doorknob, happens in nature when clouds bump around in the atmosphere and then discharge that electricity to the ground. And now we have chemical energy, the energy in between the bonds from one atom to another. In some chemical reactions, when two atoms bond together, they release some energy. And likewise, sometimes when we break those bonds, we release energy. Sugar is a great example. Sugar has a lot of potential chemical energy in the bonds of its atoms. In between the carbon atoms of a sugar molecule, there's the potential for those to break apart. And when they do, they release a bit of energy. Those carbon atoms aren't broken apart as far as fission. They're not breaking apart the nucleus. They're just breaking apart a carbon atom from another carbon atom. So this is what happens in your body when you digest food and the food particles are brought into your cells. Your body combines the sugar with oxygen, kind of like what would happen in a campfire. Under a controlled situation, breaks apart the carbon atoms, releasing a little bit of energy that you could use. Those carbon atoms you breathe out, and guess what? Plants can absorb that and use the energy from the sun to create more sugar. So a lot of forms of energy are going to start to overlap. Here's some images that might give you some clues about how the types of energy can be at least shown visually. So electricity, the nuclear fission of atom being broken apart, the electromagnetic spectrum, or at least part of it that we can see, and then here's some we can't. Thermal energy, such as lava and the heat deep within the earth. Chemical energy, like when you break the bonds of the piece of wood in a fire. And then this one could represent all of them. I see a picture of the sun. That's nuclear energy. The electromagnetic spectrum is the light waves traveling from this sun to this plant. Thermal energy, of course, there's heat being transmitted there as well. And chemical energy, because the chemical reactions of photosynthesis are being powered by the sun, and we're creating chemicals here. And there are electrons being moved in this process as well. So it looks like we have all of them. So the next few lessons we'll be talking about how energy can be transferred and transformed from one type to another, so that a lot of these images, even here, we might say this could represent thermal energy as well. Well, thanks for tuning in, guys. Hope that you can go to Schoology and start working on your project and find a couple different types of energy that you could compare to each other. And remember to store those links. Again, thanks for tuning in, and thanks for trying science. See you next time.